Hi everyone, this is going to be one of two parts for the screencasts for the week 2 extra exercises. So in this first video, I'm going to cover the VLOOKUP stuff and indexing generally. And in the second video, I'll move on to pivot tables and pivot charts. So the first exercise is all about VLOOKUPs. The first thing you need to do is download the Emissions Global workbook from LearnJCU, which is inside the week 2 learning resources folder. And then we'll go through and complete these 4 tasks. So in the spreadsheet, each of the records has an ID that's made up of its country name and the year. So if you wanted Australia in 2012, you would type Australia with a capital A and then 2012 without any spaces. So that's actually what we're going to do in the first one. So the first one asks us to look up the amount of CO2 emitted by Australia in 2012. Now over here, I've set up a little bit of a workspace for that. So if we want to do a VLOOKUP for that, we start by typing equals VLOOKUP. We open up our brackets and we search for our ID of Australia 2012. We search within the table A to M. We then give it the column that we want to return. So CO2 is in column D, which is the 4th letter of the alphabet. So we put in 4. And lastly, we set range lookup to false, because remember, range lookup it will return something that has a close match. We don't want that in this case. We only want to receive a value if we can find the ID. Otherwise, you probably want to get some sort of error message so that we can check what's gone wrong. So when I press enter on that, we will see that it returns that value for Australia in 2012. So that's the formula up the top there. The next one asks us to find the ratio per capita of emissions in Sri Lanka in 2010. So again, we start by typing equals VLOOKUP and opening our brackets. Our ID is going to be Sri Lanka with capital S, capital L, and then 2010. Table array, so again, that's the whole table that we're interested in. So our table goes from columns A to M. We want to return the ratio per capita, which is column M, so 13. And we want range lookup to be set to false because, again, we only want an exact match. So when I hit enter on that, we'll get a value for the ratio per capita. Next is the power industry emissions in Papua New Guinea in 1981. So again, we start by creating our VLOOKUP and opening our bracket. We type in the country code, so capital P, capital N, and capital G for Papua New Guinea, and followed by the year of 1981. So that has to be in quotation marks. I should have mentioned this at the start, actually. That has to be in quotation marks because this is a string data type. We talked about those at the end of the lecture last week. Strings are just anything that's a collection of numbers and letters, so text. So we need to use strings so that the VLOOKUP knows that that's the data type it's looking for. Our table array is again A to M, which is our entire table. We want to return whichever column the power industry is in. So that's in column G, which will be column 7. And once again, we set range lookup to false because we only want an exact match. Hit enter on that and we get an answer. Now, the last one asks you to find the amount of CH4 emitted by South Africa in the year that you were born. So if you're starting university in 2021 after finishing school last year, you were probably born in 2002, I think. I might have that wrong, so I'm going to do 2002. So for that, we type in, again, VLOOKUP, and we open up our brackets, type in South Africa. Here you would put in your birth year. I'm just going to use an example student of 2002. That way you don't have to know how old I am. And then we can give it our table range of AM. And we want to return the CH4, which is column F, so 6. And lastly, we want range lookup to be false. So then we hit enter on that and we get our answer for that. So I might just, I'll go through those formulas again so that you can see each of them. So if you actually go into formulas, you can click on show formulas, and that's made everything huge, but that's okay. And that'll actually show you the formulas that are there as well. So you can sort of have a look at them all at once. At least you could if it would let me drag that across further. Yep, there we go. So you can see what those VLOOKUPs were for each of those. And you can just check that back off when you're done with it. Alrighty. So that's task 1 on VLOOKUPs. The next task is about the index function. So the index function, it takes the table array, which is the size of the table, so A to M. It takes a row number and a column number. So it just sort of indexes like battleships kind of thing. So in exercise 1, we found the amount of CO2 emitted by Australia in 2012 using VLOOKUPs. So now we want to create an index function that does the same thing. So the reason I picked Australia is because it's nice and close to the top, which is handy given that we need to actually work out the row that it's in. So I'll just write exercise 2 index and merge those across. So just a few formatting things. So that merge and center allows you to combine multiple columns or rows. And we want the CO2 in Australia 2012 again. So for index, we need to know the row number and the column number. So we already know that the column number is 4 from before. When we did our VLOOKUP, we worked out it was 4. We also know that our table array is equal to A to M. So what we need to now find is our row number. So I'll scroll back over here. I'm going to scroll through for a little bit until I find Australia. There we go. And we wanted 2012. So that's going to be in row 389. So we can put that in here so that we don't forget it. And we can write our index. So equals index. We give it our table, A to M. We give it our row number of 389 and our column number of 4. And assuming I've typed everything in correctly, yep, we get the same number as we got in exercise 1. So you can see why that's a little bit more tedious. If you had quite a small database, it might be an okay approach, but for something this large, you probably want to have some sort of ID-based system in so that you can search for stuff even if you don't know where it is. So that kind of answers the reflection question, which was which method is easiest. So VLOOKUP is certainly easiest in that example. There are some case studies with smaller ones where maybe index would be suitable, but you just need to use your judgment based on the task at hand. So next we're going to recreate this little table that I've included here in a blank worksheet, and then we're going to use an if statement to check whether a person is older than 18. So then we'll use autofill to populate the rest of the rows. So let's have a look at how we'll do that. I'll open up Excel and just sort of move it to the side here a little bit and create a new sheet. Zoom in on that a little bit. So name, and some ages, 18, 16, 20, and 17. And we want to work out whether these people are greater than 18. Maybe we're seeing if they can enter a bar or get into a club or vote in an election or something. So our if statement works by typing equals if, and you'll actually see when you open the bracket, it gives you these hints. So if you, same with the lookups, if you can't remember how to use something, there's little hints here that can help you with that. So the logical test is the thing that we want to test. So in this case, we want to test whether B2, the cell next to it, is greater than 18. And if it is, we want to print yes, as we can see in the example on the left. And if it's not, we want to print no, as also seen in the example on the left. So then when we hit enter on that, for the first person, we'll say no because they're 15. And now if we've done this right, we can double click here to autofill and we can see that the results are as expected. So anyone that's greater than 18, it says yes. This person who is 18, it says no. because we used greater than, not greater than or equal to. So if we did greater than or equal to 18, the result would be slightly different. So we would type equals if B2 is greater than or equal to 18. We can do our yes, no thing again. Then that person's will actually change. So everyone else's will be the same, but our 18-year-old will be a yes instead of a no, because we're now checking whether it's equal to as well. So hopefully that makes sense. Our next question is about combining multiple logic statements. So our next one is going to involve recreating this little used car dealership table. And we're going to use and, or, and not functions to find cars that suit each of our customers. So again, I might just bring this up on the side so that we can recreate that. Zoom in a little bit. I'm just typing in the different car names as a start, and then I'll put in the year information. So our Toyota Camry is 99, our Ford is 2010, our Nissan is 2003, and our Chevrolet Impala is 1967. And then the kilometers they've driven as well. So I've just sort of got some random numbers that I've put in here, but I'll copy them out exactly. Even if you sort of put a close number, it'll still serve its purpose. Oh, that was supposed to be 81201, 312392. Oh, number lock was not on. 312392 and 230498. And then the price assigned to each of these used vehicles. So 5,000, 8,500, 25,000, and 14,500. So now we need to have a look at our different customers and what they want. So I might just create a little bit of a list here. Customer 2, customer 3, and customer 4. So customer 1 wants a car that was made after the year 2000 and is less than $10,000. So we need to check multiple conditions for customer 1. So we want to check equals and. Actually, I should have put those on the side. Let me just rearrange this table a little bit because it'll be a lot easier with autofill. All right, let's move that over. And get rid of those. So what we can do is we can type in equals and B year. So we want B2 is greater than 2000. So made after 2000 means it would have to be greater than 2000 rather than greater than or equal to. And the other condition was less than $10,000. So we put our first condition in, which is that the year is greater than 2000. And our second condition is that it's less than 10,000, not less than or equal to. So we have to do D2 less than 10,000. And then when we autofill that down, we can have a look at the conditions. So here, our Camry was made before 2000, so therefore it's false. Our Ford Fiesta was made in 2010, so it's new enough, and its value is 8,500, so it's cheap enough. So that one gets a result of true. And Nissan Patrol was made, it's new enough, but it's too expensive, so it gets a rating of false. Our Chevy Impala, it doesn't meet either criteria. It's too old and too expensive, so it gets a false for customer 1. So effectively, the car that you would recommend for customer 1 is the Ford Fiesta because it meets with their criteria. So the AND statement only returns true when both conditions are met, which is why it was useful there. Customer 2 is a little bit less fussy. They want a car that was either made after 2005, so something that's new, or something that has less than 100,000 kilometers, so something that hasn't been used too much. So we can use an OR statement here. It's actually kind of given, we mentioned in the lecture that a lot of the time logic in code is how you would say it. And this is an example of that. So they've told us directly that they either want a car that's fairly new, made after 2005, or has less than 100,000 on photo. So that means that we have to use the OR function, equals OR. So we want to check whether the year, V2, is greater than 2005. Again, made after rather than made on or after indicates that it has to be greater than, and less than 100,000, or sorry, or less than 100,000. So the other condition would be D2 is less than 100,000. Oh, sorry, not D2, C2. Wrong column. So then we can autofill that down. And we can see there's actually two cars that meet their criteria. So the Toyota Camry, even though it's old, it doesn't have 100,000 Ks. It's got just short of 100,000 Ks. So that one does meet one of their conditions. So it gets a true rating. The Ford Fiesta was new enough, and it was also, it had low enough Ks, so it gets a true rating. So all returns true if one or both of the conditions are met. The Nissan Patrol was too old, and it had too many Ks. It had 300,000 plus Ks, so it gets false. And the Chevy Impala is too old and also has too many Ks, so it also gets false. So you could recommend either of the two cars. Again, you'd probably recommend the Ford Fiesta unless you've already sold that one to customer 1. Customer 3 just wants a car that was not made before 2000. So they don't really care about the price or the Ks, they just want something that's not too old. So with that, we can just go equals not, given that the task was to use and or not to answer these questions. So we want to go not the year V2 less than 2000. And when we auto fill that, we can see that it returns false for the car that is older. It returns true for the car that's 2010, true for the car that's 2003, and false for the 1967 Impala. So what that means is that you could recommend either of these cars to customer 3. Customer 4 wants a classic car made before 1980 and selling less than 15,000. You can probably tell which car meets that criteria just by looking at it, but let's do the statement. So again, there's kind of a hint in the English phrasing. So made before 1980 and selling less for less than 15,000. That indicates that we want an and. So we're checking two conditions. So we want to check that the year, V2, is less than 1980. And the car value is selling for less than 15,000. So D2 is less than 15,000. So on a classic car, it's a bit of a fixer-upper. We autofill that down. Our newer cars don't meet the condition because the Camry, the Fiesta, and the Patrol, all of them are too new, so they all return false. And the Chevy Impala is old enough and cheap enough, so we get true for that person's car. So all in all, you'd probably sell the Ford Fiesta to customer 1, the Toyota Camry to customer 2, the Nissan Patrol to customer 3, and the Chevy Impala to customer 4, and then you would have sold all your cars. Right, so I'm going to do filtering in this video, and then we'll finish this one up, and the next one will be pivot tables and charts. So we're going to go back to our Missions Global workbook and have a look at filtering by some sort of logic. So effectively, this is just applying if statements and and statements on bulk. So the first one asks us to apply a filter to the country column and show only data from Australia. So we head over to Emissions Global. And what we're going to do is we're going to highlight all of these headings. And we're going to click Sort and Filter, Filter. And you'll see that adds a drop down next to every heading, which means we can now filter those different columns. So first up, we want to just find all of the data from Australia. So we click the arrow next to country. We can click Select All to deselect all. And then we can scroll down and select Australia back on and press OK to save that. So now we can see that all of the data is from Australia. So what we've effectively done is we've done an if statement. So if country equals Australia, show the data. So that's exercise 1. We'll clear that now. So clear filter from country. You can just press that button there to clear that. And now we have all of our data back. So the second part was to apply a filter to the year column to show data from only 2012. And then add a second filter to the CO2 column that shows only data with CO2 emissions with greater than 10,000 kilotons. So we'll start with our year column. We want to, again, click Select All to deselect everything, then scroll down to the bottom and select 2000. and press OK. And then for CO2, we want to only show ones that were greater than 10,000. So again, we can click the drop down. And here we actually go to number filters. So we want greater than 10,000. Or was it greater than or equal to? Greater than. So we want greater than 10,000. And then we press OK. So we've basically done an and statement there. We've said if the year is 2012 and the CO2 is greater than 10,000, show the data. So filters are just applying logical statements to an entire database without you having to type stuff out manually. So here we can now see that all of the data that's still included has greater than 10,000 kilotons of CO2, and it's from the year 2012. So there's not much data left there now. So once we're done with those, we can, because we've got multiple filters to clear, we just click on sort and filter over here and press clear, and that'll clear all of them. So that's another way to filter. So our next one then wants us to apply a filter to the year column, showing only data from 2012, and then add a filter to the ratio per capita column, showing only data where ratio per capita is less than 0.5. And then we want to sort that from smallest to largest. So we'll start with just filtering. So we'll go to the year column. We again want 2012, so deselect all, and then reselect 2012. Ratio per capita, we want a number filter of less than. Yep, less than, not less than or equal to. So less than 0.5. So at this point, we've actually filtered again with like an and statement. So we've said if the year is 2012 and the ratio per capita is less than 0.5, show the data. So the next thing we want to do is sort, and that was sorting by the ratio per capita. So we will click on the drop down next to ratio per capita and sort smallest to largest. It was smallest to largest, right? Yeah. So you could also go the other way, largest to smallest, but you just click the drop down and you can sort by that. So now you can see that all our data is from 2012 and the countries are from smallest to largest for the ratio per capita. So the smallest amount of emissions per person that lives there. Kind of the good countries. Okay, so that's the end of filtering. So we'll wrap up this video there, and then I'll start a new one on our pivot tables and charts to cover those few questions.